So we're going to do some more practice with our simplifying radicals. Since we learned that last class, we don't have a mini quiz on it today, so I want to do a little bit more practice with it. You do have your test next class, and as we just went over your notebook, you should have all of your numbers, 1 through 13. You're going to be getting number 13 today, which is your review packet. You'll get 13. So let's go and take a look at, we're going to work on the odd sum. So number 1, it says evaluate each expression for the given values. Round the answers to 2 decimal places. So you're definitely going to need your calculator for this because it requires the use of the calculator. Alright, so what does it mean when it says evaluate? What do we do?
Simplify it.
We are simplifying, but what do we have to do with those values that they gave us, Audrey? Right, we have to take our A, B, and C and substitute them into our equation. So we have the square root B squared. Well, B is 5, so 5 squared, minus 4 times A, and A is 1, times C, which is negative 6. Notice your square root should go all the way over to the end, because it includes all the items in it, so it should include all. Alright, and then you can put this into your calculator as is, or you can simplify it some first. So you should get the square root of 49, which was 7. Is that what you guys got? Awesome. Perfect. So we actually got a nice whole number for this. So when you're doing this, we definitely want to see the setup here, as well as the simplified answer. Okay. If you just throw down your answer and have no work, and you get it wrong, then you're going to lose all the points. So at least setting it up lets us see where you went wrong. Maybe get some fresh credit. All right, any questions on number 1? Okay, so again, evaluate. When they give you the values, you're just substituting them in. Alright, so let's take a look at these next group of odds. Remember, a square root, how many of a kind you have to have in order to take it out in front? 2 of a kind, right. Square root means we have to have 2 of a kind. 2 of a kind. How about for a cube root? How many of a kind do we have to have? 3 of a kind. Good. Just a reminder there. Okay, so number 3, we have the square root of 20. So we have to break down 20. That's your first step for our radicals. We have to break it down. I got it. Thank you, Jason. Go ahead and get out your homework if you have it, and worksheet 11. Alright, square root of 20. So we're breaking down 20. And remember, our prime factors is what we're looking for. We want to first try 2, 3, 5, 7, 9, 11, so on. Those are the numbers we're dealing with. Our prime numbers. Prime means it can't be broken down anymore. Alright, so 20 divided by 2. 10. What can we divide that by?
2.
Which gives us?
5.
Good. So what do we have? What are our pairs? Pair of 2s. Good. And 5 is all by itself. There's nothing more we can do. Alright, so we can take out our pair of 2s, cross it out, and stick them in front. Any other pairs you can pull out in front? Any other pairs? No, there's nothing else. So all that's left is our 5, which must stay underneath. 2 square root of 5. Anybody get that one? That one right? Yeah. 47. You got more than what was there. Wow. That's impressive. Alright, number 4, square root of 12x. Alright, so let's break down 12. How can we break down 12? Good. 2, which gives us? Break that down. Which gives us? Alright, we have a pair of 2s. So that means we have 2 comes in front. Can I bring my 3 out in front? Do I have a pair of 3s? So what do I have to do? Leave them in line, or leave them inside. If they don't have a pair, they can't come outside of that square root. The only way to exit the square root is if you have a buddy going with you. Alright, so that has to stay under my square root. And now let's take a look at our variable. We have just one x. Do I have a pair of x's? No, so he also has to stay under your square root. And make sure your square root extends all the way out. Questions on that one? I know. I realize it didn't be, but that's okay. Let's do an odd number. Alright. So we have a cube root. How many of a kind do we have to pull it out? 3. We have to have 3 of a kind here because it's a cube root. You must look at your index. The index is that tiny little number in front of your square root. Okay. 48, a bigger number. Finally, let's do some work. What can we break this down into? 2 and? Good. 2 and 12.
16.
And then 6. And 3. If they wouldn't have any more numbers, we're running out of room. Okay, and then we have y's. So 1, 2, 3, 4. Okay, let's look for groups of 3 now. Groups of 3. Here's a group of 3. Here's a group of 3. Any other groups of 3? What did you say?
No.
Oh. Okay, so we have no more groups of 3. So anything that was a group of 3 we can take out in front. So a 2 can come out in front. No other numbers can. A y can come out in front. And then everything else is left inside. So cube root of 2 times 3 times y. It's all multiplication in there. And what is 2 times 3 times y? Okay, 6y. So our answer is 2y, cube root of 6y. Jason, do you want to come closer? You can sit next to Elder if you want to, as long as you and Drew can handle it. You can't handle it though, we'll move the desks. Actually, to help ensure let's move just a little bit. I'm watching you. Alright, any questions on number 5? Okay. So now I want you to take a minute to do number 7 and number 9. These are pretty similar to what we just did. Do number 7, number 9. I'm going to come around and check to see how you're doing, then we'll come back together and go over that. So you look at the number that's in front. This is a square, so you'll have groups of 2. If it was a 4th, Gabby, you need groups of 4 because of that. Alright, so again, work on number 7 and number 9. I'll be coming around to see how things are going. So we'll go. Alright, so number 7 is first. We have to break down 48. Alright, what can we break it down into? 2 and? Good. Break down again. 2 and 12. Break down again.
6.
2 and 6. And again.
3.
You want to do 3? Okay.
No, it breaks down 3, but 6 divided by 2 equals 3.
6 divided by 3 equals 3?
No, 6 divided by 2 equals 1.
Yeah, but doesn't 6 divided by 3 also equal 2?
Yeah, but that's...
Yeah.
You don't like that?
No, because it's easier to group when it's the other way around.
It's still a pair.
Yeah, but it's easier to group the other way.
Okay,
Yeah, that's
alright,
all
alright.
It's easy.
No, I just want you to know that you can switch numbers in there as long as it's a factor.
Sure, that's fine.
Doesn't matter which factor you use, just as long as it's a prime factor, you can use it.
It's already complicated.
That's okay.
Yeah, I'm good on that.
Okay, and then our x to the 4th. We have x times x times x times x. And just a reminder that this is 48 times x to the 4th. That's multiplication that's happening there. So when we're breaking this down, anything in front of our square root, that's multiplication. Anything under my square root, that's multiplication. We're multiplying everything throughout here. This is x times x times x times x. This is 2 times 2 times 2 times 2 times 3. Alright, so let's circle our pairs. Here's a pair. Here's a pair. Here's a pair. Here's a pair. All pairs? Come out in front. So here's a pair of 2s. One of those comes out in front. Another pair of 2s. One of those comes out in front, and it's multiplication. Pair of X's. One of those comes out in front.
Yeah. Sure.
And then we have another pair of X's, and that comes out in front as well. Are there any other pairs?
No.
No, taking care of all of them. But what is still left over? That 3. That poor lonely 3. So 3 has to stay underneath the square root. The only way you can come out is if you have a pair. Okay, now we need to simplify. What's 2 times 2? And what is x times x? X squared. So we have 4x squared times the square root of 3. How do we do it that way? Don't lose your 3. And if it helps you out, some people like to go ahead and divide by 3 and have 1 left over, which is fine because you would have 3 and 1 underneath, and 3 times 1 is just 3. So it's the same thing. But if that helps you to not lose your factors, that's fine. All right, so we'll do number 9, then we'll come back to number 8. Because we had a request for that. All right, so number 9, we have 45x squared y cubed. First of all, what is my index? What type of root is this? Is it a square root, cube root, fourth root, fifth root, sixth root? It's a square root. So how many of a kind do I need to have? 2 of a kind. The square root is 2 of a kind. All right, so let's break down 45. 3 goes into 45. What's left? 15. What can we divide 15 by? Alright, and just to help those of you that maybe like it preferred this way, we'll go ahead and divide 5 by 5 is 1. Alright, still the same factors. You don't need to put the 1 underneath your square root. Once we're done with this problem, yeah. Alright. So x squared is x times x. Y cubed is y times y times y. Alright, so let's circle our pairs. What do I have pairs of? Good, a pair of x's, a pair of y's. What else do I have pairs of? Yeah, a pair of 3's. Any other pairs? No? Alright. So now let's go and break this down. All pairs come out. So a pair of 3's comes out. A pair of x's comes out. A pair of y's comes out. So all pairs come out. It's multiplication. Now what's left inside? 5 and y. Alright, and simplify. That's just 3xy square root of 5y. And that's it. Questions on that? Okay, so let's take a look at number 8. So number 8, we have 7 times the square root of 3 over 16. Let's review our properties. I have square root of 5/9. How can I break this up? What can I do with that? Subtraction?
Yeah.
What?
Huh?
What can I do with this? When we're dividing with exponents, you subtract exponents, but we have no exponents. We can divide, but can I divide 5 by 9?
No.
It's a decimal, right? Aubrey, what do we do? It's not times, but we do break it up over that division. That's what we learned last class. That was the front of our notes. It breaks up square to the top over the square to the bottom. Just like if I have square root of 5 times square root of 5. We can multiply it together to get square root of 25. In fact, this property right here is what we're doing every time we're simplifying my square roots. We're going backwards with it. Because what's technically happening is that we are saying, for example, number 3, what we were technically doing is saying that the square root of 20 was the same thing as 2 times 2 times 5. And this broke up into the square root of 2 times the square root of 2 times the square root of 5. Well, square root of 2 times 2 is just 2. So we're technically doing that property every single time we're simplifying these. Alright, so for number 8, we want to use this property here to help us simplify our answer there. Alright, so this becomes then 7 times square root of 3 over square root of 16. All I did was take my square root and break it up, 3 and 16. Right? And so we're multiplying here. To multiply fractions, we multiply straight across. Well, 7 is just the same thing as 7 over 1. We're multiplying here. Can we break down square root of 3? So all I did, Gabby, was I took my square root and I broke that up square root of 3 over square root of 16. Since I'm multiplying, 7 is the same thing as 7 over 1. You can leave it as 7, but you need to know that you multiply the 7 times with some time. A lot of people don't remember that, so I rewrote it so that you can see 7 is indeed on top. We're multiplying straight across. Remember, when we're multiplying fractions, we multiply straight across. Don't you dare cross multiply. Until I tell you you can. You're not allowed to. It's forbidden. You get that?
Yeah.
Forbidden. Okay. Can we break down square root of 3?
No.
Alright. Can we break down square root of 3? Stick with me. No, we can't break it down anymore. 3 is only divisible by itself and 1. There's nothing more we can do with it. Alright, so on top we have 7 square root of 3. 1 times square root of 16 is just square root of 16, right? Okay. Can we break down the square root of 16? What is the square root of 16? 4. Square root of 16 is just 4. Just 4. Remember, you can use your calculator to help you check these things. In order to find out if it's a perfect square root, put in your calculator, do the square root of 16. It gives you 4. Boom, you're done. You know? You can break it down like this, but it'd be easier just to chunk. Alright, so now we need to look to see if we can reduce. We can only reduce the numbers in front of your radical. Does 7 over 4 reduce at all? No, so this is your final answer.
So 7 times.
7 times square root of 3, all over 1. Questions on that one? So let's take a look at number 12 then, since that's kind of similar. So number 12, same idea, we want to break it up into the square root of the top over square root of the bottom. Square root of 20, look, that's a 12. Let's try that again. Square root of 20x to the 4th over square root of 49. Do you guys know the square root of 20? You do? Is it 10? 10 times 10 equals 20? No. No, it's not a perfect square. A perfect square is something that when we take the square root of it gives us a nice whole number. Our perfect squares are 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared?
Do we really have to continue going on with this?
121. 12 squared?
144.
144. 13 squared?
166.
169. 14 squared. That one's my favorite. Anybody know that one?
Yeah.
14 squared?
Good.
What is it?
Not a bad guess.
There you go. 196.
196.
I think you're nice.
And we could keep going all day long. These are our perfect squares. So these are the numbers that if you see a square root of it, it's immediately a whole number. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Because 4 squared is 16. 3 squared is 9. 2 squared is 4. That's where it comes from. Square and square root are opposite operations. They're inverse operations. They do the opposite. They undo it. Alright, so we said we can't do the square root of 20. So we're going to have to break that down off on the side. Can we do square root of 49?
Yeah.
What was the square root of 49?
So,
7. Alright, so we know that our denominator is 7. Alright, so I'm going to throw that down there. But because we cannot break down square root of 20, or because we can't do the square root of 20, we have to actually break that down. Alright, so let's do that off to the side. What can I divide 20 by?
2.
2 and 10. Which breaks down into
5.
5 and
2.
okay. And for those that like to have the final ending 1 on top. Alright. The square root. So we have to have 2 of the kind. So there's our 20 broken down. We also have x to the 4th, right? 1, 2, 3. Alright, let's look at our pairs. How many pairs of 2's do we have? Alright, here's a pair of 2's. Then we have a pair of x's and a pair of x's. Any other pairs? No. Alright, so our pair of 2's. Cross that out, 2 comes out in front. Pair of x's, cross that out, x comes out in front. Pair of x's, cross that out, x comes out in front. Any other pairs? So what do I have to do with that 5? Leave it inside. You can do times 1, but what's 5 times 1? 5. So you don't need it. Alright, so let's simplify it. Do what's x times x? X squared. Square root of 5. All over 7. Can I reduce 2 and 7?
No.
No. That's our answer. It is Coolio. Alright, questions on that? Okay, let's take a look through this. Are there particular, now that we've done quite a bit more practice, I'll let you guys kind of pick which ones you want to go over.
25.
25? I think 25 is a good one. Can we also do 23? Are you guys alright with that?
Yeah.
Oh my god.
Let's do 23.
You want to do 23 first?
Oh, 29 first.
You want to do 20?
I can't. 29.
We do like.
We'll do one of those. What do you want? 27, 28, or 29?
You're right.
You want 29?
28.
Yes. Sure.
The whole
17 and 15, you said?
the whole
Alright. So, we'll go numerical order then. We'll start with 15. Okay, again, let's break this up. I did see that. You both leave each other alone. What are we, in kindergarten? Thank goodness, it's like I feel like I'm in kindergarten. Can you just hold down my side? Just keep doing your tree. He's pulling on the tree. Alright, so let's break this down. Again, we have a square root of the entire fraction. So this breaks down into 2 over 1 times square root of 15 over square root of 3. Oh, wait. Even easier. Can we reduce 15 and 3?
Yeah.
Oh, let's do that. Check to see first if you can reduce. 20 over 49 we weren't able to reduce. And that other one we did. 3 over 16, we can reduce it. But check to see if you can reduce it first. What's 15 divided by 3?
5.
Five.
Oh, so you're gonna do the ladder.
Oh, we didn't have to do anything. That's your answer.
Yes.
Nice.
Three.
Not too shabby. Alright, number 17. Looks like we're going to have to break it down somewhere.
Oh, man.
Oh, it's not too bad.
Yeah.
Alright, 45. What can we divide that by?
5.
5. What does that leave me with? 9.
9.
Divided by? Good. Leaves me with?
2.
And then if you want to get to that final one on top. Okay. How many of a kind do we need? How many do we need? We need 2 of a kind. Good. Okay. So anytime something's sitting in front of your radical, that just stays in front. Alright, so we have a group of 3. Do we have any other pairs? No. So the only thing that can come out in front is 3. So cross out your 3's. 3 comes in front. What's left underneath? 5. And 1, but 5 times 1 is just 1. Okay, so let me simplify from here. What's 1/3 times 3?
1.
Yeah, 1/3 times 3 is 1. But do we really need that 1? Because what's 1 times anything?
1.
What's 1 times 4? What's 1 times 10?
1.
What's 1 times x? So what's 1 times square root of 5? Just square root of 5. If you leave that 1 in front, that's fine. That's perfectly fine. Does that make more sense? Questions on those 2? Are we feeling better about radicals than when we stepped in this morning?
Yeah.
Yes? Okay, good. You say Snickers? I want one now. Who said Snickers? Or like, is that Philip races?
Yeah, no.
Alright, 23. This one's not bad, there's just a lot going on. So take it piece by piece by piece. How many of a kind do we need?
5.
How many of a kind do we need? 3 of a kind. Thank you, Gabby. We need 3 of a kind. What can I break 40 down into? Kevin, put it away. 2 and what?
20.
20. What can I break 20 down into?
20.
What can I break that down into? 5 divided by 5 is just 4. It's like those birthday candle on top of your birthday. Make a wish. Happy birthday to us. Okay. And we have x times x, y times y times y times y. Ooh, look at all these z's we have. Let me ask you this.
Wait, they have 3 groups of them.
How'd you know that, Kurt? Mental math. What did you do in your mental math, though? Because you are completely correct. We will have 3 groups. How'd you know? What'd you say, Freddie? Yeah, 3 times 3 is 9, right? If we have 9 z's, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 3 groups of 3. Because if we have 9 z's and we put them in groups of 3, 3 times 3 times 3 is 9. Well, z cubed times z cubed times z cubed. There's a difference. So, I mean, obviously you can still write out all your z's and circle them. That's probably best for visuals. But you can think of your exponent divided by the root. And that's something you're actually doing on for 2. Alright, so if you think of your y to the 4th, how many groups of 3 do you think you're going to get out of that without even looking at it? Just 1 group, right? Which, again, we see that when we go through and circle it. We still have 1 left. Okay, so groups of 3 again. We have a group of 2's. Don't see any other groups of 3. Okay, so after we have circled all of our groups of 3, we start pulling things out. What can we pull out in front?
2.
I agree, we can pull out a 2. What else can we pull out in front?
1 Z.
A Z? What else can we pull out? Another Z? What else can we pull out? Another Z. And what's the last thing we can pull out? Good. So that's what we're pulling out. Any groups of 3 you bring out in front. So group of 3, cross it out, bring it out in front. Group of 3. Group of 3. Group of 3. Group of 3. Remember, this is all multiplication. And what is left underneath my poor little cube root? We have a 5. We have x times x, which is just x squared. And we have a y. Alright, so let's simplify. 2y. What's z times z times z? Good, z cubed. Now it's really important that you don't lose your cube root. Notice how it's tucked inside that cube, that radical? You also must tuck it inside. If you're afraid that I'm going to think it's an exponent, just go put a little circle around it. That's what I had in algebra 2 students do. That seemed to help out. So we know that you mean for that to tell us it's the cube root. Because if you have only z cubed, but then you don't write cube root, it's wrong, because then you're saying square root, and that's not the same thing. Kevin, my dear, are you with us? Good. Let's open up our eyes and take our notes. I'm going to buy like those fireball candles, and we just have to fall asleep and eat that. You know what that's? You know those like really hot ones?
Yeah, I know what you
What'd you
mean.
say? Although the fireball ones I think are even higher.
Fun fact, did you know that sensation of spicy is not a taste, that is your taste buds
Freaking out?
pain.
I would believe that. It is
It
pain.
is not a taste, it is pain.
Alright, so our final answer is 2y z cubed, cube root of 5, x squared y. Alright, questions on that? Okay. Now, number 25. What do you think we have to do here? We have a division. Can we reduce?
Break down the top.
Yeah, can we? Well, first, can we reduce 16 and 25?
Yeah.
We can? How so?
4 times 4.
Right, but can we, like, can we divide both of these by the same number
Oh,
to get it
no,
done?
no, you
No.
can't do that.
So we want to break it down, which is what you're saying to do. So let's first break up my square root. 16x to the 4th, y cubed, over square root of 25.
So it'll be 4.
Okay, so Jason just said the square root of 25 is, so we can go ahead and have 5 there. We've got to break down our top, though. We know square root of 16, don't we? Yeah, square root of 16 is just 4. But we do need to break down our x to the 4th and our y cubed. So x times x times x times x, y times y times y. And just because it's good for us, 16 divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. Divided by 2 is 1. Which just shows us 2 pairs of 2. So 2 times 2 is 4. Obviously, you know square root of 16 is 4. You don't need to do this work. But I'm just re-emphasizing. Okay, so square root of 16 we already know is 4. How many groups of x's do we have? We have two pairs, right? And a pair of y's. So x comes out, and y comes out. What's left underneath that square root? Y. And then 5. It's still in denominator. Alright, so we have 4. What's x times x? X squared. Squared. And then y. Square root of y all over 5. That's your answer there. Alright, then our last one we'll do is number 29. Then we'll move on to our review game. First of all, before we do that, questions on what we did with 23 or 25? We're good? Okay. Alright, square root of 300, yes! What can I break that down into? 2 and what? 1/5. What does that break down into? 2 and 25? 75. Okay, good. What does that break down into?
35. Oh,
That's not it. We can totally break down 75. Remember, anything that ends in a 5 or 0 is divisible by 5.
oh, 15.
5 and 15. Can we break down 15?
Yeah, by 5.
By 5. And 3 divided by 3 is 1. And you guys want to stop 75. Alright, then we have x. We have y times y times y. And we have z times z. Alright, groups of what? How many do we need of a kind? Okay. So here's a group of 2, here's a group of 2, here's a group of 2, here's a group of 2. Alright, what can come out in front? 5. I agree with that. What else? Good. What else? And? Alright, what's left underneath my square root? 3 x y. If you want to go back there and cross those off after you've done it to help make sure you've got it. Okay, what's 5 times 2? 10yz square root of 3xy. 10yz square root of 3x. Questions on that one?
No.
Okay. I'm going to go ahead and hand your review packet to you now, so that I don't forget to give it to you. And then we will do our review game for the remaining time in class.